NFA with epsilon moves. Now this is a bit trickier, or this is a bit different than what we are discussing as a device now. Okay. Now if you see, as I told you, DFA जो है वो prove करना difficult है क्योंकि उसके ऊपर restrictions ज़्यादा है. That is, I'm saying that delta must be a total function. Okay, whenever I want to define an NFA, I don't put any restriction. I just say that there is delta. Okay, there can be any missing transition, there can be a multiple transition kind of a scenario. That means I don't put any restriction on delta. Delta should be there. That's all. Okay, there can be missing links or missing next states in the table, or maybe one cell is occupied by multiple states. Okay, that is allowed in NFA. So NFA generally is a more generic device than DFA. Okay, and the third device in this category, NFA epsilon, which we will not be talking about today, is more general compared to, or more generic, or more loose device, I should say, less constrained device, I should say, than the NFA. So these devices from DFA to NFA epsilon are more and more general devices. So we start learning first about DFA, then we start talking about NFA epsilon, then we start talking about we start talking about DFA, then NFA, then NFA epsilon. This is the way to go ahead in the discussion. So what we learned today? So today we learned about what do you mean by determinism with respect to finite automata without output. A finite automata without output is deterministic if it shows deterministic behavior. What do you mean by a deterministic behavior as far as a finite automata is concerned? If I pick a pair of current state and current input, if I exactly know which is the next state I will be moving into, then that particular behavior is referred to as a deterministic behavior. To have deterministic behavior in finite automata without output, we need to have delta function to be a total function. What do you mean by a total function? Total function is a function mathematically that has one-to-one correspondence between the things which are mapped by that function, and it is an onto type of mapping. So correspondence is one-to-one and mapping is onto. Then such function is referred to as a total function. So if delta is a total function for any FA without output, that delta is going to be a deterministic finite automata. Now, if the delta for a finite automata without output is not total function, then such FA without output is referred to as non-deterministic FA, because when delta is not one-to-one correspondence and total function, you may have two scenarios. One, for at least one transition pair of current state, current input, you might not know what is the next state, or you might have multiple states as your next state. In both these scenarios, when you talk about device behavior, device does not know either what to do, or device has multiple choices to do operation. दोनों चीजें जो है ये एक तरह से नॉन डिटर्मिनिस्टिक बिहेवियर को रिप्रेजेंट करते हैं. Okay, and that's why this device is referred to as non-deterministic finite automata. I hope this discussion is fruitful and you have understood what do you mean by a non-deterministic finite automata, what do you mean by a deterministic device, and how do you define determinism with respect to finite automata. Anybody has so those who have understood these things, at least per se, in the discussion कि किस चीज को क्यों क्या बोला जाता है, please raise your hand. I'm just want to know how many of you have understood whatever is going around right now. कितने लोगों को समझ में आया है कि कब मैं फाइनाइट ऑटोमेटा को डिटर्मिनिस्टिक कहूँ, कब मैं फाइनाइट ऑटोमेटा को नॉन डिटर्मिनिस्टिक कहूँ, and what is the reason I say that a particular device is finite, deterministic or non-deterministic? Please raise your hands. Just want to know. Okay, those who have understood can raise their hands and keep them raised. I give you a minute to raise your hands in order that I guess the question that I'm asking you is, have you understood the concept of determinism, non-determinism, why a FA without output is referred to as non-deterministic and why it is referred to as deterministic? Okay. Okay, now I'll pose the question in reverse order. How many of you have not understood when to call a finite automata a non-deterministic or a deterministic automata? कितने लोगों को समझा नहीं है? Please raise your hand. Okay, बहुत सारे लोगों ने hand raise किया है. That means you have not understood that particular distinction. So I'll just go about it again with some example. No problem. Unraise your hands. I got an idea. Many of you have not understood. It's okay. Fine. Now we'll go back to the discussion that we were doing. So delta. So how many of you have understood what is a delta function? What are inputs and outputs for delta function? How many of you have understood what is a delta function? Please raise your hand. I just want to know कि क्या समझा है या क्या नहीं समझा है, so that I can repeat that part only. Okay. Those who have not understood what is delta function, please raise your hand. Okay, good. Anyone else has not understood? Okay, ठीक है. I'll just discuss what is that. So probably you might have missed the discussion. That's the reason. So these devices that we are talking about, they are defined like this. They have 5 things associated with them. Okay, they have set of states. They have set of input alphabets. Okay. Whenever I say q cross sigma, what I indicate here is I select one of the state from the input state. I select one alphabet from the set of alphabet. Alphabet क्या होता है? मेरे input symbols. So say that my device is taking two inputs, 0 and 1. Okay, and device has three states, q0, q1, q2. So whenever I say q cross sigma, I'm actually making a tuple, which is a two tuple or a couple. I select one state, I select one input symbol and make a pair out of it. So अगर मेरे पास तीन इनपुट है स्टेट्स और दो इनपुट सिंबल्स है, तो इट विल बी 6 पेयर्स दैट आई विल बी मेकिंग. So q cross sigma will be 6 pairs set. It is a set of 6 pairs. Okay. Now whenever I'm defining this function delta, what I'm doing is I'm selecting one pair of this set and I'm doing a mapping it on one of the things in the set Q. So what is set Q? Set Q is the set of states. Okay. So I'm doing a mapping between Q cross sigma, which is a two value tuple onto a single state. This is what I'm trying to do. I'm trying to achieve a mapping. So as I told you, there are 6 options I do have in Q cross sigma. So I'm naming those 6 options as O1, O2, O3, O4. Okay, I'm just giving you an example. O1, O2, O3, O4, O5, O6. Okay, so these are the 6 pairs that I have. Maybe Q00, Q01, Q0, sorry, Q10, Q11, Q20, Q21. This is how you can represent them. Okay, so this is the set of 6 things that I have, and how many states I do have. So I have 3 states, right? So those 3 states will be represented here. So yeah, those 3 states are Q0, Q1, and Q2. Now, whenever I say I'm trying to define a function, what I do is, and which has this kind of construction, I try to map pairs here on the left hand side set to the states on the right hand side. So what I have on the left hand side is, this is q cross sigma. Q cross sigma. Okay, and this is q. So whenever I say that I'm trying to learn a mapping or I'm trying to define a function, what I intend to do is I intend to associate one from this side with somebody on the other side. Now there are various ways. I talked about this in one of the lectures. I can have a correspondence one to one. That is one from this side. I associate two one on the other side. That is one to one correspondence. And what do you mean by into and onto? So this mapping has two properties, being either one to one, many to many, or one to many. So in चारों में से one to one correspondence means when I select O1, it is associated with only one of the three in the other set. तो एक पेयर लेफ्ट हैंड साइड का राइट हैंड साइड सेट के एक ही एलिमेंट के साथ अगर एसोसिएट है, दैट इज रेफर्ड टू एज वन टू वन correspondence. Okay, and whenever I say onto mapping, that indicates that all three of these guys, they participate in the association. There is no way that any one of them is missing. So these two properties are two distinct properties, having one-to-one correspondence and having participation from the second set completely. ये दोनों प्रॉपर्टी अगर फंक्शन में है तो फंक्शन कहलाएगा टोटल फंक्शन. नाउ यू अंडरस्टैंड व्हाट इज दिस फंक्शन. सो फंक्शन में ये जो क्यू क्रॉस सिग्मा है ना, ये क्या रिप्रेजेंट करता है, फंक्शन के क्या इनपुट्स है. व्हाट दिस थिंग रिप्रेजेंट्स, व्हाट इज द आउटपुट फ्रॉम द फंक्शन. सो दिस इज माय इनपुट ऑफ द फंक्शन, दिस इज माय आउटपुट. अगर आपको मैथमेटिकल टर्म्स नहीं समझ में आ रहा है तो इसको कंसिडर करो कि प्रोग्राम है. प्रोग्राम में एक डेल्टा नाम का मैंने फंक्शन डिफाइन किया है. Q और सिग्मा उसको इनपुट है और Q उसका आउटपुट है. Okay, where this first Q is the current state and the next Q that I am giving as output is the next state. The one that I have written over here, if current state is Q0 and then current input equals to 0, ये function का body है. This is the body of the function. Okay, which is indicated by this table. Now I hope this clears out many doubts that you might have about what I just said very quickly, that it should be one to one correspondence and on to यानी पार्टिसिपेशन पूरा का पूरा है. मतलब अगर मैं एक करंट स्टेट लूँ, एक करंट इनपुट लूँ, तो मुझे नेक्स्ट स्टेट पता है एग्जैक्टली, एक ही स्टेट होगा और नेक्स्ट स्टेट पता है. ये कब पॉसिबल है, ये वाला जो सिनारियो है, तीन सिनारियोज है यहाँ पे, ये वाला सिनारियो कब पॉसिबल है, व्हेन द डेल्टा फंक्शन इज अ टोटल फंक्शन. बाकी सब मैथमेटिक्स भूल जाओ, जस्ट रिमेंबर द फैक्ट कि हर एक करंट स्टेट करंट इनपुट को मुझे एग्जैक्टली एक नेक्स्ट स्टेट पता है, तो सिनारियो क्या रहेगा. तो मेरा ये जो टेबल में लिखूंगा या लिखूंगी, दिस टेबल इज गोइंग टू हैव एवरी सेल ऑक्यूपाइंग वन exact state, right? Then the device becomes deterministic. What if I don't have certain states or certain cell does not contain any state representation? Then that scenario is the second one. कि मैं करंट इनपुट देखता हूँ, मैं करंट आउटपुट करंट स्टेट में हूँ, करंट इनपुट लेता हूँ और उसके बाद चेक करता हूँ कि मैं कहाँ जाना चाहिए. ये मैं कहाँ चेक करूंगा, आई डू अ लुकअप इन द ट्रांजिशन टेबल. लेकिन ट्रांजिशन टेबल में जैसे यहाँ हो रहा है, दिस इज द सेकंड सिनेरियो. इफ आई नेम देम एज 1, 2 and 3. Okay, so this is the third scenario example, this is the first scenario example, and this is the second scenario example. सेकेंड सिनारियो में क्या होता है, मैं Q0 में हूँ, आई एम चेकिंग फॉर इनपुट 0, व्हाट शुड बी द ट्रांजिशन, बट सच ट्रांजिशन इज नॉट डिफाइंड. ये मैंने निकाल दिया है ट्रांजिशन. ओके, सो व्हाट इट इंडिकेट्स, इट इंडिकेट्स दैट आई डोंट नो विच नेक्स्ट स्टेट टू मूव टू. दिस इज अ नॉन डिटर्मिनिस्टिक बिहेवियर ना. आप डिटरमाइन नहीं कर सकते कि कौन से स्टेट में आप जाओगे. यू आर नॉट एबल टू डिटरमाइन श्योरली. देयर इज नो श्योरिटी ऑफ गोइंग टू द नेक्स्ट स्टेट. Okay, you are not sure about which next state the device goes into. That's why it is non-determinism or non-deterministic behavior. Okay, since the behavior is non-deterministic, the device is non-deterministic finite automata. It is already a finite automata, we know that, and now it is referred to as a non-deterministic finite automata if you have at least one state input pair for which you have this scenario 2. If there is at least one state input pair for which scenario 3 is there, तो यहाँ देखोगे कि आपके पास दो एरोज है on input 1. On input 1, you have two arrows here. So there is at least one pair of Q0 and 1. Current state, next input, or current state, current input. Okay. So now which two next state you move into, two या two से more भी हो सकता है. ये example में two हो रहा है. So I am able to either stay in Q0 or I am moving to Q1. ये दो सिनारियो मुझे दिख रहे हैं. तो अगर मेरे पास दो अल्टरनेटिव्स है, यानी मैं श्योरली बता सकता हूँ कि ये पर्टिकुलर ट्रांजिशन के बाद मैं कहाँ पहुंचूंगा. विल आई बी स्टेइंग इन Q0 और विल आई बी गोइंग टू Q1. Okay, I have a choice. So I have multiple ways of showing or exemplifying my behavior. I have multiple ways of showing off my behavior. तो इसका मतलब है मैं कैसा behavior दिखा रहा हूँ, non-deterministic behavior. That is why such device is referred to as a non-deterministic finite automata. And now if you go to first scenario, you take any pair of input state and sorry, not input state, any pair of state and current input, you will be able to predict, or you will be able to determine which is the next state the device is going to be in. And that's why this device is referred to as a deterministic finite automata. I hope this is now a bit clearer than the earlier version, because I guess I assumed कि आपको 1 1 on 2 क्या है पता है. तो 1 1 on 2 का मतलब होता है टोटल फंक्शन. डेल्टा बीइंग अ टोटल फंक्शन. ये सिर्फ वर्ड याद रखो, उसका बैकग्राउंड आपको नहीं समझ में आया तो भी ये याद रखो कि डीएफए इज एन एफए दैट हैज डेल्टा एज टोटल फंक्शन. ये आपको जानकारी हो इसलिए बताया गया है कि टोटल फंक्शन किस चीज को बोला जाता है. whenever the mapping using which the function is defined is one-to-one correspondence and onto mapping, it is referred to as total function. And if the function delta is total function, then the device operates as deterministic finite automata. For NFA, there is no restriction on delta. I can have some of the transitions absent, or I may have some of the transitions extra in the definition of delta. If that happens, then the device operation becomes non-deterministic. Hence, the device becomes non-deterministic finite automata. So, any FA for that matter, you can think of it to be generally a non-deterministic finite automata. But if we restrain it to have delta, which is total function, then the device becomes a deterministic finite automata. So, deterministic finite automata one notch up है. उसको कुछ ज़्यादा restriction है. It's a restrictive device, whereas NFA is less restrictive in its definition. The way it is defined, it is less restrictive. Okay, so that's the definition for you. What do you mean by a NFA and what do you mean